Hi, so during this video we will come across the decision tree algorithm and we will discuss about the theoretical and coding part as well. So let's have the basic libraries here: NumPy, Pandas, Matplot, PyPlot, scburn and everything, and then we are going to import the necessary packages also. Suppose, for example, your program needed data set from the other site, you can import from their features also, and their section, their link, and their website link also. So principles are going to be same as in another algorithm. In the previous video we have seen that the iris dataset is imported from the kernel part of this sklearn library. Okay, so before going further, we are going to explain this decision tree classifier. Initially it is having basic condition, and on the left hand side it is having the goal, means another goal, another condition, and on the right hand side it is having the upper condition. Again it is going to have the lower value on the left hand side and higher value on the right hand side. To help them make sense of the information, we have derived the entire tree in order to implement inside the coding section. Okay, so once I have run this command, it is going to print the feature value of the each column. Then I am going to run this iris data again in between 0 to 5. If you are not going to give the range of this data, this code will get into infinite loop. Okay, so this code is going to not going to inherit anything. So to help, it's unlikely to write your own code, rather to understand existing one. Okay, so I have just run this command. Okay, so now I am going to describe the data, and the next topic we are going to examine the data set itself and what is the shape, and it is going to find out the null value and the information of the data set. And the species part, it is going to draw a bar plot, means histogram again in between the given data set, and correspond to the histogram it is going to print the petal set as so on. Okay, so then we are having different features, what are the color, species, and so on. So during this video we have come across the coding part only. If you want to gain or acquire some theoretical knowledge, you just go to the different website given on in the description list, and you can have the different idea about this scatter plot and heat map, everything. Okay, then all these x label and y labels are ordered on the scatter plot, and then it is going to print on the screen. Then we are having TSE and LSN film. Then we are having a scatter plot on the different sections representing the class, and a typical example of this kind of operation is the decision of the selection of sales and production of the inside the company. So inside any factory or consortium, we are going to sell the product, and how much probability is there to purchase by the customer, that is the very tedious task. So in order to accomplish this goal, we are having heat map here. This is the relative component, and it is the relative feature, means how sepal length is going to depend on this species, and how this petal length is going to depend upon sepal weight. This is going to describe everything. Lighter the range, means lighter the color of this pixel value, means no relation at all. Suppose it is having 0 value, means no relation in between these two features. If it is having 1, means of course it is having correlated with each other 100%. It is more likely to 1, means 0.87 value towards 1, means it is having dependency with another variable as well. In this section we are going to split the data. That's pretty much all there is to define the training set and test set and random value, everything, and how which is while it is not necessary to print the xtrain and xtest shape number here, but we are going to define the everything. So through this invaluable and accurate process and data processing part, we have come across the decision tree. I have imported this decision tree classifier here and going to train this sklearn tree, then giving the criterion entropy and random state 0 and everything. I'm going to run this command. Okay, then briefly restate your purpose, what is the confusion matrix and what is the y prediction and y test. On the basis of the data given, it is going to predict the model. Okay, so awaiting an early response from this data set, we are having the accuracy here. Previously we were having 97.77 in KNN in the chapter 16. Now we are having 95.556. So we can improve this accuracy, means accuracy by root mean square or r square error, and so many functions are there in order to remove this accuracy. So this is how we implement. It is hereby brought to your kind information that we are going to run this decision tree and how it is going to implement. Thank you.